ChatGPT explain AI distillation like I'm 5.
Over this past week, open source AI proved that if enough pressure is put on closed AI's neck, Sam Altman will be forced back into contributing to open source. Since you're the type of person that click on this video, you likely have heard the news about DeepSeek, a Chinese AI workshop releasing open-weight reasoning models which outperform the best available paid OpenAI models. Distilling a large language model is when you create a list of millions or even billions of prompts, send them all to the large language model, and store all of the responses to fine-tune smaller language models or even train entirely new language models. In summary, Distilling an AI is using it to create synthetic training datasets to teach small language models how to respond better. While DeepSeek making the R1 models open weight was an undeniably based step forward for open source AI, there's two problems I see with this China-sponsored AI company. Problem one, releasing these R1 models as open weight could just be a big flex to convince us all to download their app to access the latest and greatest model, so they can do what we all know China wants their tech companies doing, which is harvesting all of our data to create our social credit score. Problem two, unless other non-China based developers are taking this knowledge of distilling the latest models, will simply be dependent on the China Communist Party approving the R2 models being open sourced and not restricted to their app, which now has more users than ChatGPT. Which is exactly why I am creating this video to show you all how to code a Python script to distill any leading flagship LLM. Thanks to HuggingFace, we have an abundance of open source datasets filled with high quality prompts people are sending to their AI assistants. And this makes it very simple for us to quickly create our own massive distillation prompt datasets to run on whichever model we want to distill at the time of running our script. With distillation, we could create a prompt dataset for general use by selecting datasets with widely varying topics and even multilingual prompts to get a general use distilled model, just like DeepSeek R1's models. But for smaller language models that we run locally, we can get far better performance when training them to be experts at one task instead of average at every task. So if we wanted to distill the most intelligence from a model like, say, GPT-03 into an 8 billion parameter language model to be used as our local coding assistants for only our use, adding prompts unrelated to coding is effectively sacrificing coding mastery for general use performance. If you're a big AI company, it makes more sense to train your models for general use so it has the best chance of impressing the widest audience. But that's not what we're trying to do, and we're actually trying to get an effective 8 billion parameter model for one specific task. To distill the most intelligence from a massive reasoning language model into a small language model for a specific use, you need to construct a dataset with only prompts relating to that topic or use case. To find already existing open source prompt datasets, I would recommend searching through the many being added by the hour to HuggingFace. If you cannot find a high quality dataset that's prompts perfectly aligned with the task for your expert model, here's two options I would use to fix that problem with code. Option one would be to find datasets with prompt category labeling and use a Python script to extract only the prompt category relevant to your distilled expert model's task. Option two would be to also use a Python script, but in this case to only extract prompts from the datasets containing words that would be only commonly used in prompts relating to the expert's task. And if you wanted to take things even further, you can always code an AI agent to filter through the prompts one at a time by whatever rules you tell the model to follow in a system message to find quality niche-specific prompts from any massive dataset. Again, think of small language models as ideal to be experts and not generalists. What this means is that anyone wanting the best performance from models that you can run locally, unlimited, and with total data privacy control should think about having many custom expert models in the largest size that your PC can run versus just running whatever instruct model a company open sources for general use in 100 languages. As this is YouTube, which is a video platform, this will be a step-by-step video coding tutorial. If you are the type that just wants to copy my source code, consider consider becoming an AI Austin Pro member today. By becoming an AI Austin Pro member, you unlock access to my private Discord channels where I share the written version of these tutorials with all of my source code, data, and models created in the videos weeks before the videos go live here on YouTube. You do not need the Pro membership to follow through this video, but for those asking where the source code is, there's the source code. And let's all give a thanks to everyone that is a Pro member already. I wouldn't be able to make these videos without their support. With that said, let's start the tutorial so you can learn how to use Python to distill any massive general language model into an expert small language model to run on your PC today. The first thing that you will need is Python 3.12 installed for the program we will code. To write the code, you will need a code editor. I'd recommend installing VS Code for free if you don't already have one. The next thing that you will need to follow along will be to download the Magicoder 40K distilled R1 dataset on HuggingFace. Link to that dataset will be in the description of this video. Once the Magicoder dataset is downloaded, create a folder anywhere on your PC and name it Distiller. Place your dataset file into that Distiller folder, and then we can open the Distiller folder in VS Code. In VS Code, we can click on the icon in the top left to create a new file in our folder. Within the text input field, write clean_dataset.py and press enter. This will create a new Python program in the distiller folder named clean_dataset and open that new program in the code editor window. Now this dataset that we have downloaded not only has prompts, but distilled responses attached to each of those prompts from the R170B model. But all we actually need from this dataset are the prompts so that we can run them on any language model of our choice and distill that language model with these prompts. In this video, I will be showing how to create a Python expert. You'll notice that the dataset is programming related prompts in quite a bit more programming languages than Python. So it's basically a waste of training potential when I go to fine tune a small model on the distilled dataset to have any prompts unrelated to Python programming. And that's exactly the problem that we are going to solve with this Python program. On line 1 of the program, we will import the JSON library. On line 2, from pathlib, import path. Then we can define a Python function in the program named extract human prompts. Again, this program will be coded to handle this specific dataset, so some modifications will need to be made to handle the varying file formats and column naming on the vast amount of datasets on the HuggingFace datasets. We'll set a variable as script_dir that will find the file path to the folder which this program is being ran from. In another variable named input_file, we can set it as script_dir / the full name of the Magicoder JSON L dataset. Then in output_file, we can set it to be in the script dir named prompts.jsonl. Create an empty list variable named human_prompts that will be used to temporarily store the extracted prompts. We can print a message that the program is beginning to process the dataset. Then we can write this line to effectively open and read the file content of the input file. With a for loop, we can loop through each line, aka row, in the Magicoder dataset. With these two lines, we can skip any empty lines in the dataset. Then within a try statement, we can use the JSON library to load the line from our input file into a Python readable variable named data. In a variable named conversations, we can use the JSON get function to get the conversation value from that row, specifying to the get function that it should be a list variable. In a variable named human_messages, we can create a list comprehension to effectively extract any prompt with the word Python in it. Using an if statement, we can check if a qualifying prompt was found in that row, and then we can use the Python extend function to add any prompts with Python in them from that row to the human prompts list above. Outside of the try statement, we can use this except statement to handle any errors if the dataset has a misformatted row. This will prevent that error from stopping our program and allow it to continue to the next row in the dataset. What we need now is to create a new output.jsonl dataset file with only the prompts, which we do in Python by opening the file in write mode with this W parameter. With the new file open for write writing, we can loop through each prompt in the human prompts list. In the loop, we can create a new variable named JSON_OBJ that we can set as a dictionary item with the prompt as the key and the actual prompts text from our human prompts as the value linked to that prompt key in the Python dictionary. Then we can convert that dictionary to JSON format and write it to the file with the JSON.dump function. After creating a new line in your JSON file, you'll want to create a line break. After all of the prompts have been written to our output.jsonl file, we can print a message letting us know that the program completed successfully. At the bottom of your code, you can simply call the extract human prompts function to effectively start the program. Now our code is complete, so we can save it and either hit this play button to run the script or use this command in a terminal or command prompt for Windows users at the distiller folders directory to start up the program and create a refined distillation prompt dataset. This next program will be not necessary to distill language models, but I highly recommend copying the code into a Python file for a tool in your process of distilling AI models. While we won't go through this code line by line like the previous and the next Python program that we will be creating in this video, let's go through what this code does from a high-level overview. Since language model API services charge by the token input and output, we can use this code to tokenize every prompt in our output file from the previous program, divide that number by 1,000,000 tokens since that is how these models are price rated, then multiply that number by their rate per 1,000,000 tokens. Since it's impossible to calculate how many tokens will be output depending on the model that we are distilling and the specific prompt, I have coded this program so that it assumes an average of 700 tokens will be output to each prompt, though chances are that it is a very high estimate unless the model is doing a ton of reasoning before responding. In summary, this program calculates the exact cost that you will pay in input tokens and estimates the output token cost. If the model that you want to distill is not already in the model's list, you can simply add the model's name and its pricing to the pricing list, and this program will output each model in that list's expected cost to distill on your specific output file dataset. As with all of the source code and the datasets that I will be creating in this video, this program's code is available for AI Austin Pro members to copy and paste if you don't care to type it out yourself. The last program that we will need to distill any large language model into a training dataset that can be used to fine-tune any open weight language model is the distiller script itself. So create a new file in the distiller folder named distill.py. For the sake of making this video something that anyone with any budget can follow along, I will not be making the program to distill any paid API services. Instead, we will use the Grok free tier API, which gives us a very generous rate limit of free usage and access to many leading flagship open weight models. At the end of this tutorial, I will show how to modify the program to use any paid API service. For this program, you will need to import the JSON, OS, and time libraries. You'll also need to import the Grok class from the Grok library. If you have not already installed the Grok Python library, you can use this pip command in your command line to install that dependency. For this program, you're also going to need to create and copy your free Grok API key from their site. Paste this in the quotes for a variable named API_key. Then we can create a variable named model to specify which of the Grok models we want our program to distill. Since this demonstration is creating an expert Python model, I will choose the Gwen-2.5-coder-32B model, which at the time of recording this is the best performing Grok model on coding specific benchmark tests. Then we can specify the name of that file in our program's code as prompt_file. In another variable named outputs file, we can specify the name for our dataset where all of the distilled outputs will be saved. Set a variable named max_retries to equal 3 and retry_delay to equal 5. Now with Grok's free tier or any large language model API service for that matter, we are going to have rate limits, meaning if we send more prompts or tokens in a certain time period, Grok will reject our prompt. Since our distillation datasets are going to have thousands of prompts, prompts, we need to design this program to avoid exceeding that rate limit and then spamming the API services to avoid our API accounts getting banned. Which may sound like a hassle, but it's actually pretty reasonable of them when you realize that having a Python program spam their API service after hitting the rate limit is basically DDoS attacking their expensive servers and making it harder for them to serve people within their rate limits. For these two variables, remaining request and remaining tokens, you will want to set these as the actual daily prompt limit and token per minute limit that your account's rate limit is set for that specific Grok model or whichever API service that you are using with this program. You can check that on your Grok account's limit page and put those actual numbers in for those variables in your code. We'll create a function in this file named read that will be used by the program to process our input and output JSON-L files. We'll define this save output function that will be used to write our responses as they are received from Grok to the output file. Define wait for limit, which will be the code to track our rate limit usage and create appropriate delays in the program when necessary. Make sure you change this 14400 to the number you set for remaining request if it was different for your account. Then for this 18,000, also make sure it matches the remaining tokens, ensuring that your program is using your Grok account's rate limits for your chosen model in the code. Now we can define a function named process_prompt that takes client and prompt as input parameters. In this function, set the remaining requests, remaining tokens, reset request time, and reset token times as global variables so that we can modify these variables within the function and save changes to those variables outside of the function. By writing a for attempt in range of max retries loop, we can create a loop to attempt to run the code within it to generate our responses 3 times. We want this script to have robust error handling so that it can continue to run through these massive datasets, and this allows the program to create the delays for our rate limiting and retry a request if one ever fails to generate up to 3 times. Using a try statement, we can call the wait for limits function. Then using this with statement to call Grok's unbelievably ugly named function path to generate a response, we can check our remaining rate limits immediately. As the response is streamed from the Grok API to our program, we can use this response text variable to track each of the streamed chunks. And using this for loop, we can add the chunks in real time to response text as the program receives each of those response stream chunks. Then we can use this except statement to prevent any potential errors from stopping the program and create a delay in the program running the time.sleep function for the retried delay. At the end of the function, we can simply write return none. Next, we need to define a main function in our program to handle the program's logic flow. In that main function, we start by connecting to the Grok API. We then need to create 4 variables for the program. Outputs will use our read function on the outputs file. Processed will create a list of all prompts in the outputs files. In other words, any prompts that have already been distilled. Prompts will be the entire content of our distillation prompts in the prompts file. Then with to do, we can create a list of only the prompts that have not been yet added to our outputs file with a distilled response. We can now have the program check and print a message if the to-do list is empty, letting us know all the prompts have already been processed. If the to-do list is empty, we can call return to stop the program. If the program hasn't stopped, print a message letting us know exactly how many prompts are left to be distilled and that the processing is starting. We can now have the program loop through each prompt in to do and create a variable named response to store the results from our process prompt function for that prompt. If the program generated a response successfully, we can call our save output function, passing the prompt and the response as input parameters. After saving, use a print statement to show the first 50 characters of the prompt successfully processed. Else the program did not generate a response for that prompt, so print a failed message with the first 50 characters of that prompt as well, allowing you to check if the prompt had any formatting issues or if it was simply the API and unrelated to your quality of data. After the for loop, looping through each prompt prompt in to do, use another print statement to indicate that the program has completed running all of the code successfully. At the very bottom of your code, simply call the main function to start up the program processes. Now your code is complete, so you can save this distill.py Python program. If you followed along everything to this point, you now have a Python script to use as a template to create distillation prompt datasets from open source datasets, a script to calculate how much any given model costs to distill on your custom prompt dataset, and a Python program to distill any model on the Grok API that with minor changes can be converted to distill any language model from any API service you wish to run it on. By simply modifying the code in distill.py to send the prompts to any other language model API besides Grok, pasting in the rate limits for that service, you can effectively distill any top performing massive language model into training datasets to make your local models smarter. When the program is running, you can open the outputs.jsonl file and watch it rapidly fill your distillation training dataset. If for whatever reason in the middle of the distillation process you need the program to stop and then start back up later, you can simply stop this program, and once you start it back up, it will know how to search for what prompts need to still be distilled. If you want to see how to use Unsloth's open source fine-tuning library to train the leading small to mid-sized models on your distilled dataset, check out this video where I walk through fine-tuning language models for free in a Google Colab notebook. This has been AI Austin. I will see you in the next one.